this interface looks much. I mean, the previous interface probably was it was kind of a drag, I would say. But yeah, this one looks nice. So good work. But unfortunately, we'll have to go back to WebEx as soon as we, uh, because the regular classes are probably supposed to be taken here. I just thought these days we are not getting enough students anyhow, so why not just shift here? Okay. Anyhow. Just a minute. Okay, does it work? Yes, it works. Okay, fine. So this lecture is about the input output handling in C++. Now I know that because you guys actually have a background in C++, which dates back to the previous semester when your seniors actually started you guys off with C++. So I do know that at least the basics you guys already knew, right? So I think maybe C out and C in was more natural for you guys than printf and scanf. So so this is why in the beginning I did not cover these things. Uh, the overall input output thing. Plus, I there are not too many changes between C and C++. But the reason I'm covering this in a different lecture is because from now on, you guys are going to build systems, right? I mean, I'm assuming that you are working on your projects. So one of the issues that I wanted to show you how exactly people use inheritance practically, right? So this is why I just included this lecture. I thought in this way I can also give you basic idea of the C++ IO, and at the same time, you'll also understand how inheritance is such an important concept, right? Because now you guys are going to build your own projects. So this is this IO these IO classes in C++. They are a very good live example of how inheritance can be used for writing clean code, writing code where you are not having much duplication. So this is why I thought I'll include this towards the later part of the course, and I'll show you how inheritance is being used in the C++ IO hierarchy. But anyhow, so first of all, in case you guys have forgotten the C related stuff, in fact, I did open up that lecture from ITP as well. But anyhow, let's just talk about it straight away. So there are certain things that we talked about in during ITP. When it comes to file handling, there are certain things that you already know or should know. In case you have forgotten all these things, you can go back to those ITP lectures. There were two lectures, by the way, on file handling. So all that we covered in ITP, that is also pretty much applicable to C++ as well, right? So it would not be a bad idea to simply go back and have a look at those lectures again. But anyhow, I'm just going to summarize these things. These are the things that we did in ITP, and I'm not going to go into any details of it. But yes, uh, please go back and check how to how to do these things. For example, you should now know. By the way, if you do not remember, I'm ready to explain any of these points in detail, but I am assuming you guys already know it, so I'm not going to spend much time here. So anyhow, the first thing we discussed in ITP was the difference between text files and binary files, right? So this is the basic concept that we started off with. So if, just to give you an idea, there are two types of files usually that we encounter whenever we are talking about file handling, and these two files include the files which are binary files and the files which are text files. Now the difference that if you guys remember was that the so-called binary files, the what we really do is we basically we just treat each and every byte in the file without trying to interpret them. Okay, this is the difference between textual data and the binary data. That, for example, the data that is stored in the file uses some encoding which is different from ASCII. Okay, let us say some encoding which takes two character spaces, right, 16-bit or 32-bit. So in that case, if you read the file byte by byte, you might actually just have read a part of a data item, right? But you really don't care about it, right? I mean, this is what was difference between binary data and textual data. When you treated it as textual data, you are interested in reading, let us say, one character at a time. Then you knew the concept of opening a file and closing a file, right? So there were methods called, actually I'm using the term method, it should be function. So there were functions called fopen and fclose, right? And they used to have this file pointer. So every time you wanted to work with a file, you had to use fopen or fclose, and then there used to be a file pointer. Using that file pointer, that file pointer was supposed to be passed to all the functions that you use, right? The fprintf, the fscanf, fread, fwrite, ftell, fseek, wherever you needed to do any file operation, this file pointer was supposed to be passed to that particular method. So this was because, of course, C did not had the idea of object-oriented programming. You will now see that the number of parameters will go down by one when you come to C++. Why? Because instead of passing the file pointer, you are basically going to call member functions on a similar type of class. Okay, so you don't really need to provide the object itself. It's a member function, so you can use that object dot member function kind of thing. And so you knew how different modes were there. So basically there were two differences. First of all, by default the file will open up in text mode. If you wanted it to be opened up in binary mode, you had to give that b b character as in the mode string, right? So it will not just be r, it will be rb, or not just be w, but it will be wb. These kind of things were there. But by default it was text file. It is exactly the same in C++ as well. If you open a file by default for reading or writing, it gets opened up in the textual format. If you want to do binary input output, you have to provide another flag. Okay, there. So we'll see what that flag is, but that is the idea, that you have to change that. Uh, you have to basically use a flag in order to make the compiler understand that this is not really, I don't want to read this file character by character. I want to read this file uh, byte by byte. So this is one difference that you have to understand. And then we said that in order to do the input output over a typical file, we were supposed to use some functions. These functions were fprintf and fscanf. So essentially fprintf was an equivalent of printf. So now here we you'll see that there is a similar kind of a scenario. The way you use, so the idea was, the only thing that was differing from fprintf to was this file pointer. Other than that, fprintf worked pretty much the same way as printf. So similarly, in C++, what happens is that uh, typically you perform your input output using cout and then that insertion operator. So for most cases, you will be doing exactly the same. What will you do? You'll just use a file stream instead of a file pointer, and then you'll use the same old insertion operator um, in order to put this put whatever text you want. Anyhow, so these things you guys already know. If you guys have any issues with all this, I can probably spend some 5 minutes over it. So all these things are clear. Any doubts from this part? Let me check the chats. Because the reason I'm not going through all this is that it is essentially the same. And by the way, if you were happy with the CIO, that CIO is still available to you. Okay, so any C++ compiler will also accept will also accept all the C functions, right? So it's just that you have to include the header files from the C domain. So that will be required, but so you'll have to include, for example, the stdio.h in order to use that. But other than that, if you were happy with the CIO, you can of course still use it. But C++ IO might probably be easier to use. So this is why I thought I'll just show you how C++ IO works, and of course I want to show you another thing, the inheritance part. So anyhow, any questions on this? Shall we move forward? Okay, I'm just assuming it's all clear, right? So the difference, the basic difference that is there between C and C++ is that here we use something known as streams. Okay, there you had a file pointer. Here you have the concept of a stream. Okay, so what exactly is a stream? Essentially, a stream can be considered in the real world to be a kind of a file. Okay, so if you want to, let us say, send data from one place to another, you use streams to do that. Okay, and what are the typical scenarios? So the stream could either be a one-dimensional stream. So what will be a one-dimensional stream? A stream that where data always enters from one end and then it goes out from the other, or it could be a bi-directional stream where data can flow in both directions. So you can either uh, send it from here to there, or take it from there to here. So bidirectional stream is essentially a read write stream. So where you're connecting to a source, let us say a file, and then you can either read from that file or write to that file. So that is a bidirectional stream. And a unidirectional stream is where you are only going to read or only going to write. So that is the difference. But again, going back to the C analogy, it is all about the modes, right? So you can always open a file for in the RW mode. So RW is kind of a equivalent to a bi-directional stream here. Okay, and just R or just W is kind of a unidirectional stream here in this case. The second, and this is the major reason why we are having this lecture, is the use of inheritance. Okay, the best part about C++io is that you can see how they have created a beautiful hierarchy in such a way that they don't have to duplicate these features. Okay, so whatever tasks they do it only once, and then with the help of this beautiful class hierarchy, everything works. So this is the example. There is a kind of an abstract class called iOS. I'm not sure whether it is really abstract, but I have never directly used iOS, so I'm assuming it will be abstract or kind of abstract. So this contains all the basic stuff. Okay, whatever is required to do the file handling at the bottom level. That stuff goes on in this class. So iOS is kind of the super class for all this. Then there are two classes, iStream and OStream, which inherit from iOS. Okay. Now, just to give you an idea, CIN is of type iStream and Cout is of type OStream. Right. So these two classes are deriving directly from iOS. So whatever features have been defined in iOS, they get passed on to these two classes. Then I mean, you know that iStream, it's quite intuitive that iStream is an input stream and OStream is an output stream. Okay, and then you can also do this input output using a stream called IOStream. Now, if you want to use file handling, if you want to do input output over a file, what really happens is they have two more streams, if stream and OF stream, and these streams are deriving from their respective input and output streams, which were deriving from iOS. So basically, whatever happens here, whatever thing was had added here, this gets automatically added to these classes. So for example, the insertion operator, right, it gets added into the OStream class, so because of which you can use it with cout. So that you can also use that same operator with any type of off stream. And similarly, this f stream is just a derived derived class of IO stream. So what is the significance of this hierarchy? The best thing about this hierarchy is that they have saved their efforts, right? They define the basic stuff in this class iOS. Then any stuff that is specific to inputs goes here. Any stuff that is specific to output goes here. And then this, because C++ allows multiple inheritance. This is, by the way, this is not the complete inheritance hierarchy. There are some more classes in here which I have not shown. These are just the relevant classes, but the whole C++ class hierarchy allows you to simply use a function or an operator that was defined in the base class in the derived class. So with the help of this hierarchy, the best part that you get is that any stream that you are going to create, any input or output stream, they can be used in exactly the same fashion as C out and C in. So the reason I wanted to discuss this is that now you guys are most of you, I think, are collecting the requirements for your project. I guess barring maybe maybe 3 or 4 projects, I think I have given go ahead to everyone, right? So now you are in the phase of collecting requirements for your project. This is what I expect from you guys. Okay, uh, I've said this multiple times that I do not really care much about the final code that you write and how does it look when you execute it. Okay, that I assume, that is the ITP part. You now know how to write code for a given problem, right? So you will be able to figure out figure out the algorithm, and then from there onwards you will be able to convert it into code. You also know how to write different functions, recursion, divide and conquer, all those things. In this course, the idea is that you start appreciating this kind of effort, right? So this is the effort which in some ways is what this particular course is trying to teach you, that whenever you are given a task to build, especially this, and this works only when you are building a system. If it's a single program, then all those things doesn't, right? It doesn't matter, right? You are just going to write everything in the same class or in the same function itself. But when you're going to build a system, okay, these things are going to be important, and that is what I want you guys to know, that this kind of a hierarchy, you should think that whatever requirements you have for your project, how can you model them in this kind of a hierarchy? Okay, so this is something that I want you guys to appreciate from this picture, that this is how the C++ developers, the developers of the C++ standard input output library, this is how they thought, right? This is how they structured their thought process. So I just want you guys to borrow this thought process. Okay, try to figure out the abstractions in your project, figure out how you can create an inheritance hierarchy. And of course you have the advantage in C++ of multiple inheritance. Not many languages uh, allow multiple inheritance. So this is why you can see this IO stream guy, right? I mean, this is one place where multiple inheritance can be helpful. So my point is, try to think now about your projects from this perspective and see if you can model whatever requirements you have in this kind of a beautiful class hierarchy, where you are not really duplicating anything. You start with a particular level, you add whatever is the base bare minimum, then at the next level you do some more customization, then again. So this is what I'm expecting you guys to do. Okay, let's go back. So creating and using streams, they are very simple and straightforward. This is basically what you do for taking input and output. You already know that C out and C in are there, right? C out and C in are the ones for standard input and standard output. There's another stream, by the way, called CERR. It's called the standard error stream. I'm going to show you some code directly after this presentation. So I'll show you how CERR is used. So if you want to do some kind of input output over files, these are the three streams that are possible, which are often used: if stream, off stream, or whatever you call it, and F stream. So if stream is for input, OF stream is for output, and F stream is for both input as well as output. And the way to create them is very simple. You simply provide the name of the file. And this is the way where you are passing it to the constructor of if stream directly. And there is another method through which you can explicitly open it. It's called the open method. By the way, I've forgotten to write it here, but there is a reciprocal method, right, called close. So similar to f open, there is open. Similar to f close, there is close. So after you are done with your string, you should also close it. And then similar to those mode in those modes in C where you used to write R, W, A, okay, append, for example. There are similar, modes in C++ as well. I'm not going to go into details because they are basically the same thing only. I'll just give you guys some reference points from where you can read the details about these flags. And in C we used to simply write RB. Here we use this OR operator. This is the bitwise OR, by the way. This is not the logical OR. And this is a common way, not only in C++ but in Java also, where we create these things known as bit masks. So let us say for any particular scenario, there are assume that there are five different ways, five different flags, or five different configuration options that I can choose. What the way to do that is you basically represent them as bits in a byte. Okay, you imagine them like a bits in a byte. So if the first bit is set, you say this is corresponding to this flag. If the second bit is set, you say it is corresponding to this flag, so on and so forth. And if you take a bitwise OR of all these, only those bits will be set which are supposed to be sent. Don't worry much about bitmask. So basically this is a common way to create multiple configuration options. It's not just here, you'll see it in other places as well. So this is the idea. You open a stream, you will have to provide the mode for. And by the way, this binary thing is only required when you want to open the file in the binary mode. If you do not provide any mode, then it is considered to be text mode. For binary, you have to make it explicitly. And then again, the in the read write part, there are similar ways to do this. So basically, the first thing is, instead of fprintf, the way to do it is like this: simply use the insertion operator. And why are we able to do that? Because okay, this has to be OF stream. This is what I wanted to say. This has to be OF stream. So if you create a type of OF stream, because it is a derived type of O stream, you are able to do this directly. So if you do this, hello world will be printed directly into file.txt. I think you might have already done it, but yeah. So this is the idea that these OF stream and IF stream, you can use them in exactly the same fashion as you use cout and cin. And then there are some methods as well, like read and write. And these read and write methods are equivalent to the fread and fwrite methods. So we generally use read and write for the binary input and output only. You can do it for character as well, but this is more common with the binary files. So if you remember, we used to write full structures and then read them back, right? So the same thing you can do. You can write full objects now to files using read and write, and then read them back. The for seeking, so seeking is something that we do when we want to have random access. If you want to access a particular element within the file, we used to use this seek function. And again, there were three different ways in which you could have done this seeking thing, you could have given the seek from the start, from the end of the file, or from the current location. So similarly, I think the constants for them are iOS. Okay, iOS start or iOS spec, something like that. I keep forgetting. Don't worry, you don't have to remember it. All you can always check it in the C++ template library. Template libraries, what is it, reference, right? So you can always open up the reference and check these flags. But they work in exactly the same fashion as FC. So other than the convenience of using this insertion operator, I don't really think there's too much. Of course, it's a much polished library. The C++ libraries are much more polished as compared to C. So for example, this get line method that is there, when you read a line from a file using the get line method, it will not add the slash n to the red string. These are some of the things that if you have worked with the CIO, you will know that the F scanner, for example, it'll add an additional slash n, and this slash n will be a headache for you to remove. So it is certainly a more polished version, but yeah, you can always use the C level input output in order to get through. So let me just show you some code, guys. Let me first unshare this. Okay, I'll add the additional references to this, and because I need to know. By the way, I have a book. I wanted to recommend it to you guys. Let me see if I can find it online. Uh, if you're planning to use C++ for in the longer run, there is this book. This is the book. So let me just share this. I forgot where exactly was the share thing. Here, tab. So this is quite expensive, I know, but if you would like to be a permanent developer or a long-term developer in C++, I have this book. I have the third edition of this book. But if you want to be a pro C++ programmer in the longer run, please attempt to buy this book. It's a very good book for references, right? I mean, whatever I was telling you right now, it's kind of a ready reference book. It is not a good book to learn C++, by the way. Let me be very honest. If you buy it just to start, if you start it from day one, you might be too confused. But it's a very good book to keep in your bookshelf. So I have the third edition. I'm planning to buy the fourth one as well. So if you want to be a pro C++ coder, please buy this book. This is just a suggestion. Anyhow, so let me show you some code today. I hope you guys can see the VM. Yeah, you can see this one. Okay,
Yes,
so okay, so let us start. So we are extending these toy examples, right, every time. So now in this case, what I'm going to do is I'm going to create a toy pamphlet. Okay, so let me show you what this toy pamphlet is. I was also trying to do some binary IO, but it was not really going through. So I thought I'll show you the text-based IO today. Maybe I'll create another simpler example. I was not able to see where the pointers were going wrong, so I just thought I'll show you at least the simpler example. So here is a simple example. What I'm going to do here, yeah, by the way, I'm also going to show you how to use the new and delete operators. So new and delete operators, we did not discuss them explicitly, but basically they are the equivalent of malloc and free in C++. So I have this class called toy pamphlet. The idea is to just print a pamphlet of the toys I have, and it will only print the name of the toy and the price, the price associated with the toy. The reason I'm showing this to you is because uh, we had this question as the practice lab question last week, right, where you were supposed to print something, so print the bill, I guess, right? That was the objective. Now, of course, I'm not really happy with how people have done it. In fact, I'm going to prepare the solutions now and send it over to you guys, because I feel even the TAs did not get what I wanted them to do. So so I'll prepare the solutions myself and send it to you. But there was one aspect for which students were interested. Some of you sent me emails saying that how to print the stuff in a pretty fashion like we used to do in C++. So I thought, because we are discussing the input output today, I'll also show you some of the ways in which people do it in C++. So anyhow, so there is this class called toy pamphlet, and the idea is this: you give it a list of toys, and it will generate a pamphlet for you out of it. So, and then it can also store it in a file, and things like these. I think I probably should have added another function here. Anyhow, so this is what we do: toy pamphlet.cpp. Let me show you certain things first. So there is a header file called iomanip. Okay, so this is used in case you want to use manipulators. So what exactly are manipulators? I'll show you just now. But let me, I think, first show you the output so that you can understand what this thing is going to do. So this is what happens. I'm just trying to show you how the pretty printing thing is working here. So this is the name of the toy, and then this is where the MRP is being printed, right? And even though this MRP is actually an integer, I'm just explicitly changing it to a float so that I can show you all those things. So this is equivalent to printf with %6, 2 kind of stuff, right? You remember we had those things where we wanted to do some kind of pretty printing. So we are doing something similar here. So let me show you what these things are. So there are certain things known as manipulators. What are manipulators? Whenever you are going to use, let us say, cout, you can say that for the next output that I'm going to use, I'm going to provide using this particular cout statement. I want it to be formatted in a specific fashion. Okay. One of the and to do that, you use things known as manipulators. You've been already using one manipulator. It's called the Endel manipulator. Okay, Endel manipulator you guys have already used. And what does this do? If you put an Endel there, it will just add a new line character, and then the output will be as you want. So this is known as a manipulator. Endel is a manipulator. Similarly, there are many manipulators. In fact, the reason I suggested you guys to buy this complete reference is that for me this book is great. I just open up the book and I can see all the manipulators. I'm finding it hard to give you one reference point where everything is given in such a concise form. Anyhow, so Endel is a manipulator which can manipulate your output in a way where the next output comes on the next line. Similarly, there is a manipulator called setW. What it does is it actually sets a width, right? So it is similar to saying %60. So whatever is printed, it is printed after creating a space of 6 characters. If the number of characters in your output are less than 6, it gets filled up with something else, right? You remember that part. So that is the same thing here, that the set W is another manipulator. There are a number of manipulators that are there. I'll just show you how to use them. When you call this generate pamphlet thing, this is what happens. By the way, there are two ways to do these manipulations in C++. First one is to set preferences for the stream at a global level. Global level as in, if I do out dot precision, out is a stream, by the way. If I call the precision method, then this is like a permanent setting. So from here onwards, whatever outputs I do, the precision, the precision here means the number of digits to show after the decimal point. So if I set the precision to be 2, whenever I try to output something which is, let us say, floating type, it will be shown up to the second decimal place only. I think there will be a rounding or something like that. Similarly, the width part is whenever something is displayed, it will be displayed in blocks of 8 characters. Okay, if the output is bigger than that, then the 8 part is ignored. But if it is smaller than that, some padding is done. Okay, and what exactly is this padding? This is the padding. So the fill method, with the fill method, I can provide the padding character, such that if the number of characters in the output are lesser than the width, then this character will be padded. Okay, and this is where I am printing the name of the toys. So you can see that there are some manipulators being used here. So this iOS left basically means that justify it to the left side. By default, the justification is towards the right side. So what it means is that the padding character will be filled up on the left if I do not do this. Okay, in order to put the padding character on the right, I had to make use of this manipulator. Then I'm setting the width to be 50. Now here is what is happening. The default width is actually 8 only, because I have set it using the member function. But if I just want to change it temporarily, I can use the manipulator. So this is the difference between manipulator and these functions. These functions, whatever you pass to these functions, they'll become a permanent, they'll change your stream permanently. Whereas these manipulators, they only work for this particular statement. So from the next statement onwards, the width will be again 8. But for this statement, I have changed the width to 50. So this is the difference between manipulators and member functions. Whatever you do using member functions, the changes persist across the use of the stream. And if you just want to temporarily change the behavior of the stream for one particular instance, you use the manipulator. Endel is a manipulator. Okay, if let us say, assume that there was a preference in the O stream class to set Endel as a preference. Maybe it would have meant that every output that you do is on a different line. Okay, I'm just trying to give you an example. But Endel is a manipulator, so you have to do it every time. It is not something that is permanent. Is this part clear? You understand the difference between manipulators and member functions of a string? You can ask me. Okay, I mean, this is it's not too important, but yeah, when you start if you want in your projects, if you want to output something nicely, like you wanted to do in that example in the practice lab, then maybe these manipulators can be helpful for you. Okay? Of course, I mean, you don't have to remember anything. As I said, these are all part of standard reference. So please don't feel that it's necessary to remember all the names. You can always check up some reference. But is this part clear? What is the difference between a member function of a stream versus a manipulator? That is the difference. I hope it's clear. Okay, so then so this is what I'm doing here. I'm just creating the pamphlet in a nice fashion, I would say. And then here in the second part, this fixed essentially means the opposite of scientific notation. If whenever you set the precision for a particular floating point element and you try to print it, you might see the scientific notation coming up. Okay, so to avoid the scientific notation, I have just stated explicitly as fixed. So fixed is the opposite of scientific notation. Otherwise, you will see these. In fact, let me just remove it and show it to you. Remove the fixed part. This is what will happen. By the way, how many of you have started using make files? I don't think too many people are doing that. Anyhow, so this is what happens if you do not use the fixed part, the output will be like this. That's the idea of fixed. Okay, so this was for creating the pamphlet, and now in order to put this pamphlet inside a particular file, this is what I'm doing. I'm just asking you for the name of the file, and then I'm creating an OF stream object here, and then I am just calling this so-called generate pamphlet method with the stream, and here. Uh, so this one, so you can see how this same method can be used both for printing stuff on the screen. So if I pass C out as a parameter to this function, it will print everything on the screen. Otherwise, if I create a file stream, okay, a stream that is pointing to a file and pass it here, it will behave in exactly the same fashion. Right? So this is quite convenient here, right? I mean, uh, uh, we can use cout or we can use a file string. This is similar to how we used to use stdin with fscanf. I'm not sure how many of you remember the problem with fscanf and scanf, but we used to do this. We used to pass the stdin pointer to fscanf. The same thing can be done here. You create the type of a stream and a file stream, and you can use it in a very similar fashion as cout. And there's just one more method here. I think it will be up. This is called string print the stored pamphlet. So let us say if you have already stored the pamphlet in some particular file, this is how you can read it back. There is a method called EOF. EOF stands for end of file. Okay, so what the only thing that I'm doing here is I'm using this method called get line. So a get line, as the name suggests, it basically reads everything uh, from the stream until it encounters the new line character. There are other forms of getLine as well, but this is the most common one. And then all I'm doing is I'm just putting it into a character array, a buffer, assuming that in no case will my lines within the text file is going to be greater than 80, and then I'm simply printing it from there. So EOF is a way to check if you have encountered the end of file. EOF stands for end of file, and every time you create a stream, you also are supposed to close it like this in dot close. Any questions on this? Oh yeah, I forgot to show you new and delete. Yeah, yeah. So the new and delete part, right? They are very similar to your malloc and free, right? So what was the process of using malloc and free? We used to have a pointer, and then we will do malloc, and then whatever memory gets allocated, the pointer will be set to this memory block's beginning, right? And from there onwards, you can use that memory block as if it was, let us say, an array, for example. So the same thing happens here, but with the new operator. So here, this list of toys is a pointer to toys, right? So basically, two pointers are there: toy to asterisk asterisk, and then I'm just creating an array of pointers, and each pointer in turn in this array is going to point to a toy object. That is the idea. So basically, this is from the C part only, that it is a kind of two-dimensional array. List of toys is a kind of two-dimensional array, and when you want to similar to the free, you also have this delete. Here you have two forms of delete. If you used the new operator to create an array, you should put this square brackets here, And if you just used it to create a single object, you just put delete without this, right? So this is similar to malloc and free. Uh, any questions on this? These are standard boilerplate things in C++. It's not of high importance. I just wanted to show you because I didn't explicitly cover it. I just told you that new and delete are similar to malloc and free. But I just wanted to include it in this code so that I could show this as a demo to you. Okay. Are in and out like, yeah, they're exactly the same thing, right? In and out are std in and std out. In fact, if you are aware of, if you remember std in and std out, there used to be another one called stderr. So similarly in C++ you have this thing called CERR. Okay, so this is equivalent to stderr. C in is equivalent to std in. C out is equivalent to std out. Okay, so there are actually a lot of commonalities between C and C++, and I just wanted you guys to get a glimpse of this and understand how the C++ file the IO hierarchy is made, so that you can take some inspiration from it and use it in your projects. Any other questions? Okay, so don't. I mean, the only takeaway from this lecture is to go and read that class hierarchy. To be honest, right? Everything else is just some kind of code, and you guys might already know it. But the idea is, just imagine how the C++ IO works, right? How they have very beautifully created a set of classes so that you can use the features from the top at the bottom. Okay, so the idea is, whenever you design your project, I want to see such things. Okay, I want to see such hierarchies in your projects. This is why to some people I have said, please tell me more about your project, because I don't see such a hierarchy being built in your project, right? So sorry for that, but this is what I am expecting. You guys, you should be able to come up with such solutions where I see such kind of hierarchies. Okay, any queries on this? Okay, so I'm going to reply back to some of the emails again. I mean, there are about 10 to 12 groups for which I have not replied back. So I'll do it by tonight. But please start working on your projects. I think some of you, I have already said that please, by this weekend, the next weekend, come up with your requirements list, so that you can then start from the next week. You can start designing stuff, and in the next week we'll also study class diagrams. So it is good to start as early as possible. Okay, any questions? Okay, guys. Thanks. And I think this experiment worked. We never even went close to 100 in Google Meet. If this experiment keeps working, we'll shift to Google Meet, because then we don't have to go through uh, the WebEx scenario. Okay. Thank you, guys. Bye.
Thank you, sir.